The Tech Mutiny: How Google's failed JavaScript killer breathed life into Flutter. In October 2011, Google took the stage at a tech conference in Denmark with an audacious, world-altering ambition: to assassinate JavaScript and replace it with a brand new programming language called Dart. JavaScript was running the entire web, but Google viewed it as a fundamentally flawed legacy system, messy, lacking rigid architecture, and structurally incapable of handling the multi-billion-dollar enterprise applications of the future. Armed with the overwhelming dominance of Google Chrome and the world's most powerful search engine, Google engineering heavyweights Lars Bak and Kasper Lund pitched Dart not as a minor technical upgrade, but as the foundation of a new era where web apps would run at native machine speeds. Yet, Silicon Valley and the global developer community saw right through the technical jargon, immediately pushing back against what looked like a massive corporate power grab to monopolize the open web. If Google built a custom virtual machine inside Chrome to run Dart smoothly, while rival browsers like Firefox and Safari refused to adopt it, the open internet would fragment, forcing developers to build exclusively within Google's walled garden. This intense industry resistance doomed Dart's original web ambitions to a swift and brutal death. Rival browser engines flatly rejected the new language, the developer community boycotted it, and even internal Google product teams refused to gamble their codebases on it. Dart quickly spiraled into the tech graveyard, on the verge of becoming just another abandoned project on the long list of Google's forgotten experiments. But tech history rarely follows the exact blueprint of its creators, and Dart's near-death experience became the catalyst for one of the greatest resurrections in software history. Stranded and useless on the web, Dart found an entirely new battlefield: mobile development. In a quiet pocket of Google's San Francisco office, a small rogue group of engineers began a radical, unauthorized experiment by fusing this abandoned, highly performant language with an experimental, bare-bones graphics tool called Sky. They weren't trying to fix the web anymore. They were trying to solve the agonizing nightmare of cross-platform mobile development, where developers were desperately caught between the grueling dual workloads of iOS and Android and the laggy, bloated performance of early multi-platform tools. That accidental backroom pairing laid the groundwork for Flutter, a toolkit that would completely rewrite how millions of developers build software across mobile, desktop, web, embedded systems, and the modern frontiers of artificial intelligence. The Defeat and the Dilemma: How a Tech Boycott Battered Dart and Exposed Mobile's Greatest Nightmare. Lars Bak and Kasper Lund fundamentally believed Dart was the ultimate architectural answer to the chaotic limitations of JavaScript. Outside Google's echo chamber, however, the global tech community heard a far more sinister message: the heavy footsteps of a monopoly marching into open, public territory. The industry resistance was immediate, aggressive, and highly synchronized. Tech titans Apple, Microsoft, and Mozilla flatly refused to embed the Dart virtual machine, Dart VM, into their web browsers. Adding a foreign runtime engine meant inflating browser complexity, amplifying security risks, and actively sabotaging open web standards. This coordinated boycott stranded Dart in a brutal engineering paradox. A language built to conquer the web could not run natively on the web. If Chrome was the only ecosystem pulling the weight while Firefox and Safari stood on the sidelines, Dart was no longer the future of the internet. It was just a proprietary Google gimmick. This skepticism quickly fractured Google internally. Engineering teams behind global juggernauts like YouTube, Gmail, and Google Maps refused to risk their infrastructure on a toxic, heavily boycotted language where recruitment pools, performance benchmarks, and ecosystem trust were completely up in the air. Granted, Dart held undeniable architectural superiority over early JavaScript, offering clean object-oriented architecture, strong static typing, and robust scalability for massive code bases, which is precisely why the enterprise-heavy Google Ads team quietly adopted it. But an internal corporate life support system wasn't enough to save the dream. In 2015, Google surrendered, officially announcing that it would not integrate the Dart VM into Chrome. Instead, Dart was demoted to an intermediate tool forced to compile down to standard JavaScript just to run on modern web browsers. It was a humiliating, symbolic defeat. The language that set out to execute JavaScript was now forced to survive as a parasite inside its rival's ecosystem. A corporate death sentence in all but name. Yet, as the door slammed shut on the web, an entirely new, multi-billion-dollar conflict was erupting on billions of smartphones. By the mid-2000s, iOS and Android had completely monopolized mobile commerce, banking, social media, and on-demand services, leaving engineering teams suffocating under immense architectural strain. To launch a premium mobile app, companies had to run two completely separate, redundant production tracks. One team writing Objective-C or Swift for iOS, and another writing Java for Android. Developing the exact same features and UI layouts twice doubled production budgets, paralyzed deployment pipelines, and led to fractured user experiences where one operating system consistently lagged behind the other in updates. Early hybrid cross-platform tools like PhoneGap and Apache Cordova arrived with a seductive promise of write once, run anywhere, by wrapping web technologies inside a mobile container. But in reality, this was a massive compromise. These apps were merely glorified websites trapped inside a native app shell, plagued by sluggish scrolling, heavy battery drain, and stuttering user interfaces that alienated high-end users. Mobile developers were officially trapped between the financial exhaustion of native development and the laggy, compromised reality of early cross-platform tools, and it was precisely this desperate engineering vacuum that would salvage Google's abandoned language. The Rogue Genesis: How Project Sky and Dart Unlocked the Holy Grail of 120 FPS Mobile Performance. While the tech world was busy writing Dart's obituaries, a splinter group of brilliant, rebellious engineers inside Google's San Francisco office refused to accept its demise. Led by Eric Seidel, a legendary browser engineer who had previously revolutionized Apple's WebKit before joining Google, this team was drowning in the sheer, unyielding architectural exhaustion of Google Chrome's rendering engine, Blink. They knew firsthand that the open web was fundamentally paralyzed by its own greatest asset, backward compatibility. Because a modern browser is legally obligated to perfectly render broken, ancient HTML and CSS codebases from decades ago, every rendering engine on Earth carries millions of lines of legacy bloat. This continuous technical debt was an acceptable price to pay to keep the World Wide Web alive. But Seidel and his team looked at the agonizing state of mobile app development and asked a radical, history-making question. What if we completely burn down the old bridge? What if we strip away HTML, abandon CSS, bypass the operating system's native UI kits entirely, and build an engine that physically paints every single pixel directly onto the smartphone screen? This audacious, rogue experiment was codenamed Project Sky. Unlike the sluggish, cross-platform tools of the era that simply crammed a website into a mobile wrapper, Sky didn't want to copy native apps. It wanted to out-render them by operating as a high-performance, independent graphics engine. But a state-of-the-art UI engine is completely useless without a programming language built to fuel it. Seidel needed a language that was blindingly fast for end users, strictly architected to manage massive enterprise scale, and highly flexible for developer iteration. Enter Dart. To the outside world, pairing a rejected, heavily boycotted web language with an unproven, experimental graphics engine looked like a desperate corporate suicide pact. In reality, it was a profound act of engineering survival. The pairing unlocked Dart's secret architectural superpower, its unique dual compilation pipeline, a feature that single-handedly resolved the eternal conflict between developer speed and user performance. During active production, Dart utilizes just-in-time JIT compilation. This means code compiles on the fly, allowing developers to alter a layout, tweak a motion curve, or change a color and immediately see the results on a live device without rebuilding the entire app, the foundation of what would become Flutter's revolutionary hot reload. Then, the moment the app is ready for deployment, Dart pivots to ahead-of-time AOT compilation, ruthlessly baking the codebase down into raw, native machine code. This dual-engine architecture granted developers the lightning-fast iteration cycles of web programming alongside the raw, uncompromised execution speeds of native code. The ultimate validation of this rogue alliance came at the 2015 Dart Developer Summit. Eric Seidel took the stage and launched a live demo of Project Sky on Android. Without a lengthy corporate pitch, the team let the screen do the talking. The application loaded instantly, scrolling through complex layouts and transitions with flawless, buttery precision, before flashing an unprecedented, industry-shattering performance benchmark: 120 frames per second. The developer revolution: how Hot Reload and Alibaba anchored Flutter's enterprise empire. In an era where 60 frames per second was the gold standard that native mobile apps struggled to maintain, a cross-platform prototype clocking in at a jaw-dropping 120 frames per second was an absolute technical earthquake. It shattered the long-standing industry prejudice that multi-platform code was doomed to be laggy, compromised, and visually inferior to native apps. The secret lay in Flutter's complete architectural rejection of traditional cross-platform frameworks. Legacy tools operated like a decorator who constantly had to beg the landlord to bring furniture out of storage. They relied on an exhausting, high-latency bridge that translated app code into native OS UI elements step by step, resulting in heavy rendering lag as app complexity grew. Flutter, by contrast, operated like a master painter who brings their own canvas, brushes, and pigment into the house. Armed with its own built-in C++ 2D graphics engine, Skia, Flutter didn't ask iOS or Android to draw button components or render layouts. It calculated the pixels itself and drew the final interface directly onto the glass. This absolute control eliminated platform dependencies, ensuring a flawless, visually unified experience across completely different operating systems. Yet, industry-shattering rendering speed was only half the battle. To spark a true developer mutiny, Flutter needed to cure the absolute worst daily operational nightmare of mobile engineering: the agonizing weight of the compile cycle. In traditional native development, tweaking a button's color, adjusting a padding layout, or rewriting a text line required developers to recompile the entire application, wait for the emulator to reboot, and manually click through multiple screens to verify the change. A tedious process repeated hundreds of times a day that actively strangled engineering momentum and creative experimentation. Weaponizing Dart's just-in-time JIT compilation during active production, Flutter introduced Hot Reload. Suddenly, developers could hit save on a line of code and watch the visual update flash onto the test device in under a second. More crucially, Hot Reload preserved the substate of the application, If an engineer was deeply embedded in a multi-step checkout funnel or an authenticated registration screen, the app remained exactly where it was. It was the engineering equivalent of a painter watching their brushstrokes immediately materialize on the canvas, rather than waiting for the entire painting to reprint after every single adjustment, closing the frustrating gap between code and creation. This emotional breakthrough converted the developer community overnight, but enterprise adoption required an entirely different level of proof. Corporations do not risk multi-million-dollar digital assets based on a charismatic Google I/O presentation. They demand battle-tested infrastructure capable of handling massive traffic spikes, erratic user behavior, and relentless business scaling. That ultimate test of enterprise viability arrived via Asian tech titan Alibaba. While Google officially launched Flutter 1.0 in December 2018 to signal the toolkit's production readiness, Alibaba had already gambled on the framework to power Xianyu, its massive second-hand marketplace boasting tens of millions of active users. Xianyu became the ultimate crucible for Flutter, proving to the global tech industry that a single code base could not only maintain buttery smooth rendering under immense real-world stress, but could drastically cut corporate production costs by consolidating disparate engineering teams. Flutter had officially evolved from a rogue, backroom technical experiment into an unassailable global powerhouse, ready to conquer mobile, desktop, embedded systems, and the impending frontiers of artificial intelligence. The real-world crucible: how Alibaba's scale built Flutter Boost and triggered the multi-screen empire. A commercial e-commerce platform at massive scale cannot survive on high frame rates alone. It demands flawless image scrolling, instant user feedback, and bulletproof transactional stability under heavy concurrent traffic. For tech giant Alibaba, completely abandoning years of legacy native code to rewrite their infrastructure from scratch with Flutter was a multi-million-dollar financial and operational impossibility. Instead, they had to solve a much more complex engineering puzzle: injecting Flutter piecemeal, letting cross-platform screens seamlessly intertwine with pre-existing native layouts. To survive this hybrid reality, Alibaba engineered an open-sourced Flutter Boost, a high-performance integration framework that allowed enterprise teams to deploy Flutter widgets inside legacy native environments without bloating memory or breaking navigation flows. By proving that Flutter could safely refactor a digital juggernaut like the Xianyu marketplace, slashing feature development and deployment cycles by a massive 30%, Alibaba sent a definitive message to the corporate world. Flutter was no longer an indie developer tool loved merely for hot reload. It was a battle-tested, commercially viable architecture capable of driving massive enterprise ROI. Capitalizing on this momentum, Google officially aggressively scaled its ambitions, asking a natural architectural question. If Flutter can paint pixels on a phone screen, why not on every screen? This birthed Flutter 2.0, 2021, and Flutter 3.0, 2022, expanding a single Dart codebase across iOS, Android, Web, Windows, Mac OS, and Linux. This cross-platform evolution caught the attention of Canonical, which partnered with Google to integrate Flutter directly into the core OS infrastructure and next-generation installer of Ubuntu Linux. For the notoriously performance-sensitive open-source Linux community to embrace Flutter proved its technical maturity, propelling the framework into embedded systems, smart appliances, and the premium infotainment displays of modern connected vehicles. This massive ecosystem expansion dragged Dart out of the shadow of its early web defeat. Completely optimized alongside Flutter, Dart introduced game-changing features like sound null safety, systematically eradicating null pointer exceptions, the single most expensive and common runtime crash in software engineering. Dart was no longer viewed as the language that lost to JavaScript. It was now the highly performant engine driving a multi-screen empire. Yet, this rapid, multi-device expansion exposed a brutal performance bottleneck on modern 120 Hz smartphones, known in the developer community as jank. On high refresh rate screens, users immediately detect micro stutters and dropped frames during complex screen transitions or fast scrolling, instantly cheapening the premium feel of an application. The root cause of this jank was a deeply embedded architectural flaw in the Skia graphics engine, runtime shader compilation. Shaders, the small GPU-executed programs responsible for rendering complex visual gradients, blurs, and shadows, were being compiled on the fly while the user was actively using the app. This sudden GPU bottleneck caused dropped frames, resulting in noticeable micro-stuttering. While early workarounds forced developers to manually pre-compile or warm up these shaders, this manual process was complex, error-prone, and unsustainable for rapid development. Recognizing that a framework promising native fluid motion could not tolerate rendering lag, Google launched a massive, deep-level architectural overhaul to replace Skia entirely, custom building a brand new rendering engine from the ground up, Impeller. Architected specifically for modern, low-overhead graphics AP, is like Apple's Metal and Vulkan. Impeller completely eliminates runtime shader compilation jank by aggressively pre-compiling all graphic assets during the application's initial build time, guaranteeing buttery smooth, uncompromised 120 FPS performance on premium enterprise software. The engineering legacy. How Impeller, Shorebird, and the AI revolution built Flutter's undying ecosystem. Modern digital interfaces have long evolved past basic squares and static buttons. They are complex, multi-layered ecosystems defined by fluid physics engine motions, heavy Gaussian blurs, alpha channel blending, and intricate typography systems. To protect Flutter's core promise of flawless rendering across disparate hardware, Google's introduction of Impeller wasn't a minor framework patch. It was a massive, deep-level architectural overhaul engineered explicitly for low-overhead modern graphics APIs. On iOS, Impeller directly commands Apple's Metal API. On Android, it aggressively pipelines instructions via Vulkan. By bypassing the traditional runtime shader compilation traps that plagued Skia, Impeller drastically dropped frame execution latency and systematically eliminated microstutters. Beyond the raw performance metrics, this massive engineering investment sent a definitive shockwave of trust through a developer community historically terrified of Google's habit of abandoning projects. Google proved it was fully prepared to gut and replace the deepest, most foundational layer of its framework to defend its long-term architectural integrity. Yet, a truly bulletproof tech ecosystem cannot rely solely on its parent corporation. It requires open-source maturity, a reality proven when Eric Seidel, the legendary foundational architect of Project Sky, departed Google in 2023. Seidel didn't turn his back on Flutter. He left Google to solve the ultimate operational bottleneck of mobile distribution, the grueling high-latency App Store and Google Play approval delay. Alongside industry giants like Felix Angelov, the creator of the block architecture, Seidel founded Shorebird to finally bring high-performance code push capabilities to Flutter applications. To circumvent strict native platform sandboxing rules without sacrificing raw execution speed, Shorebird custom-built a highly specialized, modified fork of the Dart runtime engine, featuring a custom-built interpreter. For enterprise companies, this is a multi-million-dollar insurance policy. If a critical payment gateway or high-stakes banking interface breaks hours before a massive shopping holiday, engineering teams can instantly push a micro-patch directly to users' devices in under a second, bypassing traditional review lines entirely and proving that the ecosystem had successfully outgrown Google's internal office walls. As the tech landscape aggressively shifted into the modern frontiers of artificial intelligence, Flutter's architectural gamble on Dart finally paid off. AI-driven applications no longer just send a text query to a cloud server. They demand real-time streaming audio pipelines, concurrent contextual UI updates, high-fidelity emotional animations, and heavy background multi-threading. This is where Dart's isolated execution blocks, isolates, and its ultra-efficient event loop became an unassailable competitive advantage. Through unified cloud interfaces like Firebase AI, developers can execute complex voice-to-voice models and streaming context layers in the background without stealing a single clock cycle from the main UI thread. A modern AI-driven mental health app built on Flutter can seamlessly process ambient noise cancellation, stream live audio packages, and translate natural speech syntax concurrently, all while the interface continues to paint buttery smooth emotional animations on a premium 120Hz display. Looking back at the decade-long journey from the 2011 conference in Aarhus to Project Sky in 2015, and finally to the AI-infused frameworks of today, Flutter stands as one of the most remarkable resurrections in Silicon Valley history. It was never born from a flawless corporate master plan. It was forged through radical pivot, adaptation, and pure engineering survival. A language that was boycotted and broken on the open web discovered its true destiny on billions of mobile devices. A rejected tool met an experimental graphics engine in a quiet San Francisco office, closing the frustrating gap between human imagination and machine execution. Flutter didn't change how the world writes software because it had a flawless launch. It redefined modern app development because it possessed the raw technical resilience to survive its own failure, proving that when highly performant code meets the right engineering problem, even a forgotten project can rise to conquer the tech industry.